Good day everyone, I am Teresa Jane Ogam, and for this video I will discuss the biography of Mr. Gottfried Wilhelm Leibniz. So this is the face of Mr. Leibniz. So who is Mr. Leibniz? So Mr. Leibniz was born on July 1, 1646, and he died on November 14, 1716, and he was born in Leipzig. He was born in Leipzig, Germany. So, what are the contributions of Mr. Leibniz? So, he is the best known for his contribution to the field of mathematics and philosophy, having invented calculus independently of Isaac Newton for his development of the philosophical school of rationalism. Leibniz wrote extensively on logic, work had an enormous impact on the Enlightenment, and he was advocate for the concept of mechanistic of nature and established the scientific view of the universe. He also developed the binary number system, which is basis for the modern computing, and is created with introducing the I Ching of the West. He was the first to recognize the importance of the law of conservation of the energy, and he laid the groundwork for the field of symbolic logic. He also made important contribution to the field of probability and the game theory, and his work on calculus has been highly influential. His influence can be seen in many modern scientific and philosophical theories.
Good morning, everyone. I am Liza Miandi Dabales, and I will be the one to continue the discussion about Mr. Leibniz. So as what Teresa discussed earlier, he discussed about the biography of Mr. Leibniz. So today, I am going to tackle about the works of Mr. Leibniz, which is the harmonic triangle. So can someone still recall this triangle? Yes, that is the Pascal's triangle. So after reading the Pascal's treatise about the arithmetic triangle, Leibniz created his own variation, which is the harmonic triangle. Consider the Pascal's triangle, except for all sides which are 1, every entry of this triangle is the sum of 2 entries above it. So for example, in the column 2, we have the entries 1 and 1. So if we add these 2 entries, we will get the sum, which is 2. So we will now have the third column. And to get the fourth column, we just need to continue the process. So we will add the 2 entries above it, which is 1 and 2, and you will get the sum, which is 3. On the other side also, 2 plus 1, and we will also get the sum, which is 3. Now we have the fourth column. So to get the fifth column, we just need to continue the process. So that's how Pascal created his arithmetic triangle. But suppose you formed a triangle whose sides were the harmonic sequence, which is 1 over 1, 1/2, 1/3, 1/4, 1/5, and so on, then fill in the remaining entries as the sum of the 2 entries below it. So for example, we have the entry 1/2. So to get 1/2, we need to add the 2 entries below it. So 1/3 plus 1/6, and that will be 1/2. However, if we still don't have the value here in the center, then all we need to do to get the value is to subtract 1/2 and 1/3. 1/2 and 1/3, then we will get the value 1/6. And we will also do the same in the other side. 1/2 minus 1/3 is equals to 1/6. And to check if it is true, we need to add the two entries below 1/2, which is 1/3 and 1/6, and we will get 1/2. So we will just need to repeat the process. So in the next column, 1/3. So to get 1/3, we need to add the two entries below it, which is 1/4 and 1/12. So that will be 1/3. But also, if we don't have still the value, then you just need to subtract 1/3 minus 1/4. Then we will get 1/12. We will also do that the same in the other side and repeat the process until we create a harmonic triangle. So to make it short, or to make it more precise, so to get 1/3, we need to add the two entries below it. So 1/3 is equals to, the entries below 1/3 is 1/4 and something. So 1/3 is equals to 1/4 plus something. So we need to subtract 1/3 minus 1/4 is equals to 1/12. So therefore, 1/3 is equals to 1/4 plus 1/12. And that is the two entries below it, 1/4 and 1/12. Now consider in your entry, for example, the entry 1/2. So it is the sum of two entries below it, which is 1/3 and 1/6. So 1/2 is equals to 1/3 plus 1/6. However, 1/6 is also the sum of the two entries below it, which is 1/12 and 1/12. So we change 1/6 into 1/12, 1/12 plus 1/12. So therefore, 1/2 is equals to 1/3 plus 1/12 plus 1/12. However, 1/12 is also the sum of the two entries below it, which is 1/30 and 1/60. So we also change 1/12 to 1/30 plus 1/20. So 1/2 is equals to 1/3 plus 1/12 plus 1/30 plus 1/20. And we just need to continue the process until infinity. So if we continue, 120 is also the sum of the two entries below it, which is 1/60 and 1/30. So we will just continue until 1/3 plus 1/12 plus 1/30 plus the two entries below 120, which is 1/60, 1/60 and 1/30. 1/60 plus 1/30. So we just need to continue the process until infinity.
Good day, everyone. First of all, I would like to introduce myself. My name is Christy James Taperla, and today I will be tackling about harmonic triangle and Pascal's triangle. On this video, students will recognize problem-solving techniques appropriate to a given situation, including the development of mathematical models, the identification of assumptions, the understanding of the limitations of model, and the use of numerical methods. And also, students were able to demonstrate the use of Leibniz triangle to understand, solve, and generalize problems. First, what is Leibniz harmonic triangle? Leibniz harmonic triangle is a triangular arrangement of fractions in which the outermost diagonal consists of reciprocal of arithmetical triangle. So, arithmetical triangle is also called Pascal's triangle. In order to create arithmetical triangle, simply need lang nato i-add ang two given numbers nga naa sa babaw niya. For example, tara, sa arithmetical triangle or Pascal's triangle, ang ato gamit ang base, ang outermost part sa iyang pyramid is natay given nga 1 number, or ang number niya nga nasa gawas is 1. Now, 1 plus 1 equals 2, 2 plus 1 equals 3, 3 plus 1 equals 4, 4 plus 1 equals 5. Same process siya, there sa pika side, para makuha na to ang iyang first column or first element sa arithmetical triangle. If mo continue ka sa iyang second column or third, fourth, simple lang gihapon. Same process ang buhaton. So, 3 plus 3 equals 6, 6 plus 4 equals 10, 10 plus 5 equals 15, and so forth. So, pwede ka, amo na siya ang atong value sa first column, second column, third column, kani siya, amo na siya ang value na to. Kani nga mga column. So, atong first column dere is ang kani mga 1, second column is mo na ni ang 1, 2, 3, 4, and so forth. Third column is 1, 3, 6, 10. By the way, if ever sad nga mukanta sa iyang first column, mo na siya. Kani nga part is dili tani i-appeal sa ato ang paglitok. So, asa ta dapat mag-start sa Pascal's triangle. Kaitan maingon tag third column sa Pascal triangle. Mo na siya ang 3, 6, 10. Depende kung asa ang gipangayo nga part sa pyramid niya. Now, in harmonic triangle, each column of this is formed by taking quotients sa first column with the corresponding columns of the arithmetic triangle. So, for example, if ever nga dili pa ta kay bow, mo create sa harmonic triangle, simple na kay na siya. So, ato lang i-minus or i-subtract ang naa sa iyang left side or right side. So, for example, 1/2 minus 3. Pilay value? Sakto. 1, 6. 1, 6. Same process gihapon atong buhaton. 1/3 minus 1/4. Sakto. 1/12. Next. 1/4 minus 15. Same process gihapon na atong buhaton. Ato lang gining i-subtract ang given ang naa diri nga side in order nga makakuha ta sa iya mga values diri. Kani. Diri. Para makabuhat ta og pyramid. Same process atong buhaton. So, we have here 1/30. 30. 1/42. Same process sa right side. 1/6. 1/12. 1/30. 1/42. Now, kung makuha gyapon nato para makuha nato ang kaning nga mga values diri ug diri, simple same process gyapon natong baton. Ato lang gyapon siyang i-subtract in order to get the value of these numbers. So, 1, 6 minus 1/12. Sakto. 1/30. 30. Sakto ba? 1/30. So, ingana ra na siya pagbuhat sa harmonic triangle. Simply, i-subtract na nato yung mga values manaa sa iyahang right or left side. Ingana ra siya. Same process in buhaton para makuha nimo ang second and third column, fourth column, and so forth. So, mo na ato rong first column, second column, third column sa ato ang harmonic triangle. Now, according to Leibniz harmonic triangle, again, each column is formed by taking quotients sa iyang first column with the corresponding column sa alternative triangle. For example, again, now nanatay mga value dire, pwede na to gamiton kani nga part ang third column. Kani pwede ta na i-add. So, 1/3 ato isot dire ha. 1/3 1/12 1/30. Para makuha daw ni siya, ato daw ni siyang i-divide sa third column sa Pascal's triangle. Asa ang third column sa Pascal's triangle? Sakto. Tara. Yan. Ganun. Which is ang 3, 6, and 10. So, ato i-try. So, in harmonic triangle, each column of this is formed by taking quotient sa first column with the corresponding columns of the alternative triangle. So, for example, ang column sa 1/3, 1/12, 1/30, and so forth. Simply, ato i-divide sa third column sa Pascal's triangle. Asa ang third column? Mano siya? 3, 6, and 10. Now, kung ato i-divide, mo niya mo gawas. 1/3 divided by 3 sa iyang denominator, ang answer niya is equal to 1 over 1, 1 over 1, 1/2, 1/12 divided by 6. Ang answer is 1/12, 1/2. 1/2 divided by 6. Ang answer, 1/2. 1/30 divided by 10. Answer, 1/3. So, ang ganin siya nga mga sequence, makita na to siya sa atong first column. Mga na maka-create po si Leibniz o harmonic triangle. So, na siya relations good. Now, tungod kay each column ni consist sa differences sa elements sa left, musunod na siya sa elements sa columns up to a certain value nga makita ni Leibniz principle as the difference sa first and last values. And example, makita na to, 1/2 kani, ato na i-try og add kani nga mga values. 1/2 plus 1/6 plus 1/12 is equal to 1 minus 1/4. Now, kung ato siyang ganiron, 1 minus 1/4 equals 3/4. 3/4. 1/2 plus 1/6 plus 1/12. Answer, 3/4. So, same. Muna siya ang rule ni Leibniz. No? Kung ato i-add, simple ha, at kung ato i-add, kani nga mga sequence, ang answer niya, 3/4. 3/4. Now, sa kaninga rule, Leibniz can create infinite sums because, according to him, the more terms taken, the smaller the last value of the preceding sequence became. So, magkaalam kataas, magkaalam siya kataas. Like, for example, himo na to 1/2 plus 1/6 plus 1/12 plus 1/30 plus 1/40 and so forth, nya i-minus nato siya sa kaning value kana. Ang answer niya infinite na, no? In order to sa iyang rule, maka-create na ta og infinite numbers, infinite terms, infinite sequence. No, so dili siya ingon jud nga naa siya exact nga value if mogamit ta sa harmonic triangle sa Leibniz, kang Leibniz nga rule. Leibniz nga rule. Therefore, Leibniz was able to derive sequence na, like for example, 1/3 plus 1/2 1/12 plus 1/30 plus 1/n plus 1 n plus 2 divided by 2 plus equals now, kani nga sequence, no? Kani siya nga formula n quantity of n plus 1 times n plus 2 divided by 2. Makuha na nato ang number of terms or number of sequence or number nga gusto natong kwaon sa value. No? Mao ni yang gipasabot nga nahimo na siyang infinite. Why? It's because magkapuno siya, mapunan ang mga values nato dire sa line sa atong sequence, makuha na nato dire. Ang answer gihapon is still 1/2. And now, according to him, magkagamay ang values, magkapunan ang mga value nga atong i-add dire, maka-create na ta og infinite numbers. Mao na ang main point sa kang Leibniz. Now, by dividing the sequence by 3, he was able to rewrite it as sum of the reciprocals of the Pascal's triangle. Now, try na to i-divide. 1/3 divided by 3, 1. 1/12 divided by 3, 1/4. 1/30 divided by 3 equals 1/10. And so forth. So, according to him, ang reciprocal values aning mga answers is maka-create tag Pascal triangle. No, so asa na niya makita? Makabuhat na ta sa iyang next nga column. Mo ni siya. And so forth. And so forth. Mo ni ang main point ni Leibniz. Which, ang harmonic triangle, ang Pascal's triangle is nasa relation. And sa harmonic triangle is maka-create kag sums nga infinite. And that will be all. Thank you.